All right, let's get right into it. This is a story that, believe it or not, starts in a small workshop with a single, simple cup made of liquid plastic. And where does it end? Well, it ends with rockets, literally roaring into space. We're going to unpack the incredible origin story of the 3D printer and figure out how it completely, and I mean completely, reshaped our world. And you know what? That's not some kind of exaggeration. It's the absolute truth. Think about it for a second. Everything from the custom-fit hearing aids that millions of people wear to the tools being printed right now up on the International Space Station, it can all be traced back to one single revolutionary moment. So that's the big question, isn't it? How on earth did a simple little cup made from liquid plastic back in 1983 lead to 3D printed rockets today? To really get it, to understand this insane future we're living in, we've got to go back to the very beginning. We need to look at the idea, the invention, and the entire industry that sprung up from it. First up, rockets from resin. And look, to really grasp why the story matters so much, you just have to look at what's happening right now. We're printing jet engine parts, we're printing surgical guides perfectly tailored to a single patient, and yeah, you heard that right, we're even printing rocket engines. This technology that kicked off in '83 is, well, it's quite literally launching us into the future. But to truly appreciate how wild that is, we need to understand the world it came from, the world it replaced. Okay, so let's jump back in time, the world before layers. Imagine it's before 1983. If you wanted to, make something, a physical object, you basically had two main ways to do it. Just two.
So your first option was what we call subtractive manufacturing. The easiest way to think about this is like a sculpture with a block of marble. You start with a big chunk of material and you just chip and carve away everything that isn't the thing you want. Your other option was formative manufacturing. This is more like pouring liquid plastic or metal into a mold to get the shape you're after. Now, these methods work, for sure, but they had massive problems. They needed super expensive tools, they took forever, and if you wanted to make something really complex, especially with intricate details on the inside, forget about it. It was often totally impossible. The bottom line was simple. Your imagination was always stuck, limited by the tools you had.
And this is where the story gets really good. A curing idea. This is where our hero, an engineer named Chuck Hall, steps onto the scene. He was working with these coatings for furniture, stuff that would harden instantly under UV light. And while doing that, he had this brilliantly simple idea that would just completely leapfrog all of those old problems. He called it stereolithography, or SLA for short. And the concept? It was just revolutionary. He thought, okay, instead of carving something away or forcing it into a shape, what if? What if you could just grow it? What if you could build it from the bottom up, one paper-thin layer at a time, using a special liquid, a photopolymer resin, that would instantly turn solid wherever you shined a UV light on it?
So how does it actually work? Well, that huge idea breaks down into just 4 simple steps. Step 1, a computer takes a 3D digital file and slices it up into thousands of super thin horizontal layers. Think of it like a deck of cards. Step 2, a UV laser zaps across the surface of that liquid resin, precisely drawing the shape of that first layer, and bam, it instantly hardens. Step 3, the platform the object is sitting on dips down just a tiny bit, a fraction of a millimeter into the vat. And step 4, the laser goes again, drawing the next layer on top of the first. You just repeat that layer after layer after layer, and a solid physical object literally rises right out of the liquid. It's like magic.
All right, so building an industry. Chuck Hall had his proof of concept, that little plastic cup he made back in 1983. But, having one cool invention in a workshop is one thing. Turning that into an entire world-changing industry, that is a whole different ballgame. And things started moving pretty fast. Just look at this timeline. After that first part was printed in '83, he got the crucial US patent for it in 1986. Just 2 years later, in '88, his new company, 3D Systems, shipped the very first commercial machine, the SLA 250. And then, you see that date? 2009? That's a super important one. It's when key patents on a different competing technology expired and it changed everything. We'll circle back to that in a bit. Now, let's be clear. These first machines weren't for your garage hobbyist. The price tag was a whopping $185,000. To put that in perspective, that's nearly $500,000 in today's money. So the first people to buy these were the big players, companies like Boeing and General Motors. And the big question is, what were they using them for?
The killer app, the thing that made it all worth it, was something called rapid prototyping. Before this machine, if an engineer designed a new part, getting a physical model made could take weeks of work by a highly skilled craftsman. It was slow and expensive. But now, with stereolithography, an engineer could finish their design at the end of the day, hit print, and come in the next morning to a physical, tangible part sitting on their desk. It was an absolute game changer. It just blew the doors off the old design cycle and massively sped up the pace of innovation.
So the revolution spreads. Chuck Hull kicked the door open, for sure, but he wasn't alone for long. Once the idea was out there, other inventors in the 1980s started coming up with their own similar ideas, really broadening the whole field of what we now call additive manufacturing.
And you can see here just how diverse these new approaches were. So you had Chuck Hull's stereolithography, which cured liquid resin, but at the same time you had Scott Crump, who invented something called fused deposition modeling. Now, this is probably the one you've seen before. It's that classic desktop 3D printer that lays down a thin line of melted plastic, like a hot glue gun. Then there was Carl Deckard, who developed selective laser sintering, which used a powerful laser to fuse together powders, layer by layer, powders of plastic or even metal.
Okay, remember that 2009 date I told you to keep in mind? Well, this is where it pays off. As those early foundational patents started to expire, it was like a dam breaking. It just triggered an explosion of innovation. All of a sudden, brilliant people all over the world could legally build on these ideas, and that led to this massive wave of low-cost desktop printers. This was the moment the technology escaped the labs of giant corporations and landed right in our garages, our schools, and our small businesses. It was the democratization of making things. And that brings us right back to today, our printed future. From that one little workshop in California, this one idea has grown, it's evolved, and it's become a technology that is, no joke, fundamentally changing how we make, well, everything.
I mean, the sheer range of what we're doing with this is mind-blowing. Think about this. Almost every single custom hearing aid in the entire world is 3D printed. General Electric is printing fuel nozzles for their LEAP jet engines that combine 20 different parts into a single, lighter, more efficient piece. Surgeons are literally taking a patient's CT scan, printing a custom surgical guide from it, and using that to perform safer, more precise operations. We're even printing tools up on the International Space Station. The list just goes on and on. It's staggering. And of course, the economic scale is just massive. Right now, the market is over $20 billion. But look at the projection. It's expected to basically quadruple, hitting over $80 billion by 2030. So yeah, this is not some niche little hobbyist tech anymore. This is a core, fundamental pillar of modern manufacturing.
So what's the big takeaway here? What's the fundamental shift? For centuries, manufacturing was all about one thing: standardization, making millions of identical items as cheaply as possible. 3D printing just completely flips that script. It doesn't care about making a million of the same thing. In fact, it rewards customization and complexity. You can create a crazy complex internal lattice structure, something that would be impossible to make any other way, and it often costs less than making a simple solid block, just because it uses less material. Complexity is now free. And that right there is the ultimate legacy of Chuck Hull's invention. From digital bits to physical atoms. It's the very first technology that built a direct bridge from the digital world of ideas to the physical world of things. It allows us to turn the ones and zeros on a computer screen, digital bits, into real, tangible atoms with a kind of freedom we've just never had before. A future that, as we now know, really did begin with a single cured layer of resin.